Hi guys, this is the last set of formula that I will tell you to remember. Okay, in differentiation, if you haven't yet read the function, this log function, then you have to go back and watch that video where I explained log function. Okay, so y equals to log of x to the base b. It means if y is log of x to the base b, then it means that b raised to power y is actually equal to x. So, okay, so I can't explain the whole log function here, but this is the basic. If y is log of x to a base b, then b raised to power 4 equals to x. Let me give you a simpler example. Say, if y equals to log of 100 to the base 10, then 10 raised to power y should be equal to 100. So what should be the value of y? Y should be equal to 2. So this is a different type of function. You need to study it. We will need to use it in some physics chapters. So if you know this function, then it's very good. Let me give you another example. Say log of 16 to the base 2 is equals to y. So in this case, 2 raised to power y should be equal to 60. What should be the value of y? Y should be equal to 4. So when we differentiate this function, y equals to log of x to the base e. Okay, e is Euler's number here. So y equals to log of x to the base e. When we differentiate this function, we get dy by dx equals to 1 by x. For now, you should just remember this formula if you have not read log function. You will be needing it there. So y equals to log of x to the base e is, when you differentiate it, it gives you dy by dx equals to 1 by x. Okay. Similarly, there is another function y equals to e raised to power x. E is again Euler's number. I hope you have heard about it. Euler's number. Okay. So I'm not going into much detail of how and what is the importance of this. You will learn it when you read those chapters. So y equals to e raised to power x. This is the only function which, when you differentiate it, remains same to same. How is that possible? Why is the differential of a function is same as the function? The logical thing to say here is that for the graph of e raised to power x, the slope of the graph at any point is equal to the value of the graph. Can you understand that? Remember, dy by dx was slope of xy curve, right? So if I ask you to make a curve such that the slope of the curve is equal to the y coordinate, the slope of the curve always matches the value of the y coordinate at that point, then the graph will be this graph, y equals to e raised to power x. So when you differentiate this function, it remains as it is. Okay. Also remember, if I ask you to differentiate y equals to e raised to power 10x, then the differentiation will be dy by dx is equals to e raised to power 10x. But now there is a function inside another function. Now first you differentiate the outer function, then you differentiate the inner function 10x. So differentiation of 10x will be 10. Got it? So your final answer will be 10 into e raised to power 10x. These two formula will be used much later in physics. Okay. For now they are not that important, but still you should remember these two formula. Okay. Keep watching to learn the use of differentiation in physics. Okay. In the next few videos we will learn the use of differentiation in actual problems. Okay.